Okay guys, let us try this one. Okay, so let us see on partial fraction. Huh? Alright, okay. So the first thing you must know the condition when are you going to use the partial fraction. If you check from the textbook, if we have the same textbook, they say you only use the partial fraction. They're saying when the degree of the numerator must be less than of that of the denominator. Né? They're saying you only use the partial fraction when, say, for example, they give you your numerator is less than the denominator. Né? Alright, okay. On 2, they're also saying the denominator must have complete linear or quadratic factors. Né? So your denominator must have the factors, or you must be able to to split this into 2, né? Or into two brackets. Né? Like for example, you see that I have two brackets here. They're saying you are only going to use when your numerator is less than the denominator, and if you can split this into 2, or if when it have to what it have the factors. Né? Alright, okay. So let's do this one, for example, and pay attention before you get lost. Okay, so the first thing they're saying, they gave you the integral of what? Of 3 minus x and then x squared minus 5x. Né? The first thing that you must do, you must split this into what? Into 2, like for example what I have here. Né? For example, if I can look on this side, the common factor of what? Of x, né? Because I have x squared minus 5x, so I can take the common factor of what? Of x. Né? So this same is what? The integral of 3 minus x divided by x and then x minus 5. Ne? So it means now I have two factors. I have x and then I also have x minus 5. Ne? You're going to use this formula. You're going to say equals, and then so you're going to divide each and every term with its own denominator. Ne? On your a you divide with the first one, and then on b you divide with the second one. Ne? For example, here I'll say a divided by x, ne? Which is the first part of the denominator, plus b divided by the second part. Ne? Can you see?
Yeah.
Okay. Which is x minus 5. Ne? You understand this part? Ne? Alright, okay. And then from here, I'm going to multiply the whole equation with my denominator. Ne? Which means I'm going to multiply this my denominator of this with everything of this, and even this one. Eh? So when you're multiplying, you're going to multiply by x minus 5. Ne? When you go to this part, you are going to multiply with what? X minus 5 again. Eh? On this part, I'm going to multiply with x minus 5. Ne? You understand this part? So you multiply everything with your denominator. Ne? So if you multiply, I know this denominator you cancel with this. Ne? When you're multiplying. So now I'm left with what? With 3 minus x, ne? On this part. And then is equals to, when you multiply this x you cancel with this one, ne? You're gonna have a and then x minus 5. Ne? I go to the next one. If I multiply this one, we cancel with this. Ne? I'm gonna have plus b x. Ne? Alright, okay. And then what do you do next? I have the bracket, which means I have to simplify this bracket. No? This is same as what? 3 minus x is equals to a x minus 5a plus b x. No? Alright, okay. So from this stage, after you have simplified on your bracket, no? What you are going to do, you are going to find the values of what? You have to find the values of what? Of a. You also have to find the values of what? Of b. Nah? Alright, okay. So since I have two unknowns, guys, there's no way I can just find my value of what. If I was having only one unknown, it was going to be easy for me to get the value. Nah? But in this case, I have two unknowns. Nah? Okay, so you're going to take what we call the coefficients. Nah? So you check with your equation. I'm going to take the coefficient of what? Of x and of a constant. Ne? And if I'm saying I'm taking a coefficient, guys, I'm going to look on my equation. Wherever I see x, I take the value, which means I'm going to formulate what? An equation. Ne? Okay, let me show you how you do it. I said this side, you take the coefficient of what? Of x. Ne? I'm going to formulate an equation using this expression, which is this. Ne? Wherever I see x, I write a value. Ne? You see that on this side I have a negative what? Negative x. Ne? Which means the coefficient of x here is what? I only have one x ne? On this part. This is minus 1 ne? Is equals to. And then I look for the coefficient. Wherever I see x, I write the value. Ne? Here I have what? I have ax, ne? Which means I can write the coefficient which is what? Which is a. Ne? Okay, and then I also have, it's gonna be plus, and this side I also have what? Bx, ne? So it's gonna be plus b, ne? Alright, okay. Which means I'm done taking the coefficient of what? Of x, ne? What is the other coefficient that I can take? I can take the coefficient what? Of a constant, ne? Alright, okay. Let us see on a constant I have what here, guys? I have what? I have 3, ne? So here I have 3 is equals to, and then 3 is equals to what? Which other one you have? If a constant, it's only this, ne? So it's gonna be equals to minus 5a, ne? And please note the reason why I'm formulating this. I said I must find the value of what? Of a. I must also find the value of what? Of b, ne? Alright, okay. So let us see which one is easy first. I can find the value of what? Of a. How do I get? I just divide with what? Negative 5, ne? And then my a is equals to negative 3 over 5. So now I have the value of what? Of a, ne? What's next? I have the value of a. Now I need the value of what? Of b. So I can just substitute wherever I see a, I substitute with this, ne? So this same as negative 1 is equals to negative 3 over 5 plus b, ne? Alright, okay. And then I can transpose this one to this side. So it's gonna be plus, just say negative 1 plus 3 over 5 and see what this is your b. Negative 1 plus 3 over 5. Negative 2 comma 2 over 5. Alright, okay. So now guys, you have the value of what? Of a, ne? And I have the value of what? Of b, ne? Alright, okay. So on this, guys, if you check on your original equation, it says this part of the original equation, ne, is equals to this side, ne? So instead of writing this part, I can write this other side, because I know this is equals to that, ne? But on this one, you have how many expressions? You have 1 and what? And 2, ne? So instead of writing the original one, I'm going to write this part of what? Of a and what? And b. Because now I know the value of what? Of a. I also know the value of what? Of b. Okay, so this same is equals to, what is my value of a? This one? It's negative 3 over 5, ne? Divide by, and then what was my my value? It was x, ne? Plus, what is my value of b? Okay, it's negative 2 over 5 divided by x minus 5, ne? And please remember that we have an integral, so I can write dx, ne? Alright, okay. So this, guys, this same thing, I have this expression on its own, ne? I'm going to integrate this part. I'm also going to integrate this part. So this same is what? The integral of what? Of negative 3 over 5 divided by x, ne? Dx plus the integral of what? Negative 2 over 5 x minus 5 dx, ne? Okay, and what did I say when you have a constant when you're integrating? I said whenever you have a constant inside here, you have to take the constant outside, you remember? Okay, so it means I can take my constant of what? This same was what? Negative 3 over 5, the integral of what? Of dx divided by x, ne? And then here is going to be minus 2 over 5, the integral of what? Of dx divided by x minus 5, ne? Okay, is equals to. So now, guys, when you are on this part, you do those other methods. It depends. It can be type 1, it can be type 2, it can be the E type, it just depends. No? So now you have to integrate using the types that we're doing. No? Which type is this one? I have a fraction here. It's type 2, no? Because I know My f at x is what? It's x, right? F at x prime is 1. Eh? Is there need for me to correct? There's no need, man. Okay, so this is on this side, I'm gonna have -3 over 5. And then type 2, what is the formula for type 2? It says ln of f at x, né? Which is ln x plus c. Né? Okay, let us see on the side, the next side. Which type is this side? Also a fraction, it can be type 2 again, eh? Whereby your f at x is 1, x minus 5, your f at x prime is 1. What is my f at x prime here? It's 1, eh? Because if I integrate x, if I derive x, I'm going to have 1, and then for a constant is 0. Ne? Is there need for me to correct here? No need. Ne? So it's going to be minus 2 over 5 ln of my f at x, which is 1. What is my f at x? Is this, ne? Which is x minus 5 plus c. And this is your final answer. Ne? Okay, so basically what did we do? I said when the giveaway integral of this, ne? For you to use partial of this, your numerator should be less than the denominator, ne? And you're going to separate this thing into 2. Ne? Alright, okay. Let's say for example, I said we take the common factor of what? Of x. I was having x and then open bracket x minus 5. Ne? And then you're going to say on your a you divide with the first term, and then on b you divide by the second term. Ne? After that part, you have to multiply everything with your denominator. Ne? When you multiply with everything with your denominator, you're going to formulate an equation like this, ne? And then you take the coefficient. So on this one, I can say I can take the coefficient of what? Of x, and then I take the coefficient of what? Of a constant. Ne? I find the value of what? Of a and b, and then when I come that side, I'm gonna do the normal integration that we're always doing. Ne? You understand? Okay, you can copy this and then we can do a different one.